today I'm interviewing Adam Paszke about PyTorch, an open source deep learning platform that provides a seamless path from research prototyping to production deployment. Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you've got everything you need to scale. And for those tasks that need fast computation, such as training machine learning models or building your deployment pipeline, they just launched dedicated CPU instances. Go to pythonpodcast.com/linode, that's Linode, to get a $20 credit today and launch a new server in under a minute. And don't forget to say thanks for their continued support of the show. And don't forget to visit the site at pythonpodcast.com to subscribe to the show, sign up for the newsletter, and read the show notes. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers. And to keep the conversation going, go to pythonpodcast.com/chat. To learn and stay up to date with what's happening in artificial intelligence, check out this podcast from our friends over at the Changelog.
Practical AI is a show hosted by Daniel Whitenack and Chris Benson about making artificial intelligence practical, productive, and accessible to everyone. You'll hear from AI influencers and practitioners, and they'll keep you up to date with the latest news and resources so you can cut through all the hype.
As you were at the Thanksgiving table with your friends and family, were you talking about the fear of AI?
Well, I wasn't at the Thanksgiving table because my wife has forbidden me from doing so. It's off limits for me, lest I drive her insane because I never stop.
New episodes premiere every Monday. Find the show at changelog.com/practicalai or wherever you listen to podcasts.
Registration for PyCon US, the largest annual gathering across the community, is open now, so don't forget to get your ticket and I'll see you there. You listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with O'Reilly Media for the Strata Conference in San Francisco on March 25th, and the Artificial Intelligence Conference in New York City on April 15th. In Boston, starting on March 17th, you still have time to grab a ticket to the Enterprise Data World. And from April 30th to May 3rd is the Open Data Science Conference. Go to pythonpodcast.com/conferences to learn more and to take advantage of our partner discounts when you register. Your host as usual is Tobias Macy, and today I'm interviewing Adam Paszke about PyTorch, an open source deep learning platform that provides a seamless path from research prototyping to production deployment. So Adam, could you start by introducing yourself?
Hi everyone, I'm Adam Paszke, and I'm one of the lead developers of PyTorch. And as a day-to-day occupation, I'm a student at the University of Warsaw in computer science and maths.
And do you remember how you first got introduced to Python?
So I started with Python as part of my university courses. It was kind of a special course that let you skip the basic, let's say, web development courses, database theory, and stuff like this. We still kind of needed to pass exams on those. But it was really cool because it was a selected group of people who were supposed to maintain a system which is used for judging submissions at the Polish Olympiad in Informatics. So basically, people are submitting source code for programs, for algorithmic questions, and then you have a whole system which kind of compiles them, evaluates them, and displays the results. And this is written in Python. It's open source. So yeah, I was working on this for a year. And so that's how I got started. Then I had a bit of a break, but then came back and stuck around for a few years working on PyTorch now.
And so before we get too deep into PyTorch specifically, I'm wondering if you can start by explaining a bit about what deep learning is and how it relates to some of the terms around machine learning and artificial intelligence that people might be familiar with.
Basically, deep learning is a specific, let's say, a subset of machine learning. There are a lot of different machine learning methods, and deep learning is let's call it a set of algorithms or a set of models which got really common in the recent years because it allowed people to like train models which empirically work better with like real world data and like can, classify images or generate audio and like all this stuff, which was really hard using the previous state of the art methods. So it's really like an algorithm that's kind of taken over the field and like revolutionized in the remaining years. And machine learning versus artificial intelligence, I guess it's kind of a philosophical question if they're the same or not. So it's just a subfield, I would say.
And so can you describe what the PyTorch project is and some of the story and motivation around your creation of it?
So PyTorch is, first and foremost, it's really a deep learning library written mostly in Python. It's kind of designed around Pythonic semantics, and it really tries to embrace them so that people kind of, have a single mindset when they're writing their programs. It really attempts to be like very composable with Python programs, but also like at a somewhat lower level, like a view that I've been trying to push different places, like in one of my talks at PyCon, for example, is that PyTorch really is somewhat like Numpy, except it has some nicer features, which Numpy today lacks. And then, there's all of those deep learning helpers that are on top, but this is not really like the only kind of viewpoint on what PyTorch is. And kind of the, let's say, two most important features which are missing from Numpy are accelerator support. So you can do computation on GPU, for example, and high performance automatic differentiation. A bit about the motivation for creating it. So PyTorch is really not like, it didn't come out of the void. Basically, like it grew out of Torch 7 project, which was another machine learning library, except it was written in Lua. It's a library that I basically used before PyTorch existed because I wanted to learn more about machine learning. And the only problem is that, even though I really liked the library, even though I really kind of liked the design, I often, when you kind of went on the internet and you kind of saw the comments, everyone was like, yeah, it's a nice library, but like it's in Lua. So Lua has, unfortunately, like in almost inexistent scientific computing ecosystem. So like if you're missing a package, you kind of, you better know C and like write bindings to like C functions that let you like load, audio files, which is like a relatively standard use case, let's say. So, Lua was kind of a pain point for the library. So I kind of had this idea. I was involved a bit with the development of Torch 7, not from the beginning. I actually came like relatively late in its lifetime, but I did send a couple of pull requests. And so basically, like I was following the news, and I was trying to help with like decoupling of some of the core parts because like the math was happening in a C library that was then exposed to Lua. I kind of helped decouple the C parts from Lua parts. And so, seeing that everything, all other libraries are in Python and people are really liking Python, this kind of idea of, starting to write Torch, but in Python sprung to my mind. So that's kind of what I started working on. Then I also talked to like Sumit Chintala, who was a maintainer of Torch 7 at that time. And basically, like we kind of started working on this, and then also not only ported the whole Torch 7 implementation to Python, we also kind of improved on a lot of the pain points that people had, kind of making it even more seamless to do the research they want to do.
And as you were creating PyTorch and porting the Torch 7 library, was there any consideration of it not being an open source project, or was that something that you just established as sort of a default because of the fact that the Torch 7 library was already available and you just wanted to continue its legacy?
Yeah, we never even considered making it closed source. Torch 7 was completely open source, and even when we started working on this, there were already so many open source alternative libraries that you could use to train and like do research or deploy those models to production, which were open source, that, basically there is kind of no space for closed source solutions, I think, in this area at least. They're like the open source solutions have too high quality for that to happen, I believe.
And as you mentioned, there is already a fairly large and growing ecosystem of deep learning and machine learning tools, particularly built for Python. So can you describe how PyTorch fits into that current landscape, particularly in relation to projects such as TensorFlow and CNTK and the Cafe2 framework?
So that's a good question, because we have a lot of today we have like a lot of different frameworks which it seems like they're trying to solve the same problem. And basically the reason why people keep creating new frameworks is that I think that like a lot of people saw like the existing ways of expressing those problems in using the tools that were available to them insufficient. And so they really wanted to change how they express things. And so, there were a lot of people had different opinions. And so people who differed in how they want to approach those problems, they essentially started creating different groups, which kind of developed separate frameworks, right? So kind of PyTorch comes out of one of those groups, which was also kind of revolving around Torch 7 previously. So kind of that's the reason why there are so many libraries, I think, which attempt to do the same. And even today, we are still unsure like what's the right answer to how those things should be expressed. And so like all of those libraries are really iterating. Like if you look, they really change between versions. Even in PyTorch, like we went through, I think, a few iterations of like the syntax for the most basic things you can do with the library, just so that, it's the easiest for people to do. Regarding comparisons with TensorFlow, at least, because I think that's what I'm, the most familiar with. TensorFlow just comes from a slightly different background. Like PyTorch arose from a group that was kind of interested in machine learning research. And so the thing we embrace the most is user experience and kind of hackability and just basically the ability to like tweak every single thing in the library to kind of do the thing that you want it to do, such that you have almost no limitations if you actually want to experiment with like new crazy models and you just want to try out some crazy ideas. TensorFlow, on the other hand, I think it was mostly developed as like an inference platform. So like the first and foremost thing they kind of put for TensorFlow, I think, at the beginning, it definitely changed since then, was that like it can efficiently execute all of those computations. So TensorFlow in like the version 1, basically instead of like using the Python program to actually run the computation, the Python program was really like a meta programming language, which would build a TensorFlow program. And then TensorFlow would have a completely separate interpreter, which would actually evaluate like whatever structure kind of your Python program built, right? So those are like two fundamentally different approaches, and they really started from two places. But like both have their own limitations. So like, the approach that PyTorch takes, where you basically use Python code to kind of drive everything, is really nice because it feels natural. And in fact, if you look at TensorFlow 2, the second version, they basically put the let's say, PyTorch mode, which is called eager mode in TensorFlow 2, as the default, because that's like something that is most intuitive to users. But at the same time, they still have the like good base for efficient inference on like, heavily distributed systems or on mobile systems, which are relatively restricted. And so this inference part was something that was like missing from PyTorch at the beginning. And so now with PyTorch 1.0, we're kind of making up for those issues by like writing the PyTorch compiler, which like can take your Python source code and then like interpret it as some program in some interpreter, which we implement inside our libraries, which can then be shipped to like mobile phones and so on. So I think they just started from like, basically every framework started from like a slightly different set of primitives. And, as time passes by, as developers see what kind of things people like to use, they will basically start to converge on the same fundamental set of principles that they build their software on. And so that's, I think, what is happening nowadays. So yeah, the distinction definitely used to be much larger than it is today. Everyone has still their own biases, like from the earliest days. So, but like everyone just keeps converging to the same point, I think.
Yeah, it's definitely interesting as I've been hearing about some of the, as you said, convergence in terms of the primary concerns between TensorFlow and PyTorch and some of the other deep learning libraries, where you were saying that PyTorch started from the perspective of user experience and TensorFlow started from the perspective of performance, and just through natural evolution and using useful ideas from each other, you're starting to tend towards the same set of capabilities, but with a slightly different overarching feel and mission for what the projects are originally intended for.
Yeah, I mean, just to kind of clarify what you said, obviously we like held performance in very high regard from the beginning as well. It's not like we,
Right.
we've been trying to kind of match the performance of TensorFlow starting from day zero, which I think was pretty successful. The only difference is that like to run PyTorch programs, you really need Python interpreter, and that's not possible in like every single case. Like you really won't be shipping Python with your mobile app, right?
In terms of being able to make effective use of PyTorch, how much advanced knowledge of things like machine learning or artificial intelligence or neural network topologies should users know in order to be able to build these different models or experiment with PyTorch?
So I don't think it really takes a lot to get started. Like ultimately, PyTorch is used to teach deep learning in like a lot of courses, like both at traditional universities, like at Stanford, I know it's used for like their deep learning course. It's used at like EPFL. So you definitely can use PyTorch even if you don't know anything, because even online, like if you look up Fast AI, you'll basically find resources which will tell you how to like start doing those things entirely from scratch. But then like as you kind of will start learning those things, you'll obviously like, see more and more advanced features and start to use them. So I don't think there's like a really high bar for this. You can look up PyTorch tutorials as well for that matter. So you should be able to start with like almost no knowledge except for, let's say, linear algebra and like basic calculus, I think.
And in the tagline for PyTorch, it says that it provides a seamless path from research prototyping to production deployment. So can you talk to some of the features of the library that enable that transition and some of the edge cases that users should be looking out for as they are making that transition from exploration and trying to reach a particular outcome and then actually getting it ready for deploying into production for end user interaction?
Yeah, so this is definitely a kind of slogan of our 1.0 release, because as I mentioned, those were kind of the points which were slightly weaker previously. Like you really couldn't export PyTorch code which would run without Python. And so the way we try to approach this right now is, since we don't really want people to like rewrite too much of their programs, because we really believe that like Python is very nice for research, and ultimately, like if you look at the development cycle of deep learning models, it's like you're going through a lot of iterations of research, and like you'll be trying different experiments with like different parameters, and only after you're like through all of this, which requires you to like change your program entirely many times, you will like reach a single successful solution which you will eventually like want to, let's say, deploy to a mobile phone. And so this is basically when those features come in. And so the way we currently like recommend to do this, so there are two most important ways. One is tracing. So if like you have no significant use of control flow, let's say in the representation of your model, you can basically like just run a function on example inputs and we'll kind of record every single PyTorch call that happened inside. And later we will be like able to replay the exact sequence of those calls. This is not something that solves every problem, because sometimes you really have models which kind of, run for a different number of steps depending on different inputs and so on. And so tracing wouldn't basically export such models correct. And so there, what basically you should use if you have control flow, which you want to export, is called a script mode. And so this is basically like a set of decorators you can put on your functions. And so what they will do is they will inspect the source of your function, they will analyze the source code statically, and based on this, they will decide if like they understand what's in there because, we call it torch script. It's basically a subset of Python which conforms to Python semantics. So like every single torch script program is a valid Python program. It's just not necessarily the other way around. But if your function happens to be written in the subset that we understand, we can basically encode this using some kind of internal representation that we have. And later this can be like encoded in a file and exported and like run from pure C++ environments. Basically, there's like a shared library that you can link to your to any application, and you can use that to later run inference of your model. So that's how it's done.
And is that export artifact the Onix binary, or ONNX, for anybody who's not familiar with it?
No. So Onix is one way to do this, and it's like the, let's say, standardized way. But apart from like Onix, while being great to exchange between frameworks, it still doesn't really cover like all of the operators that PyTorch has. And like TorchScript has a lot more features, like, it supports lists, it supports dictionaries, it supports custom like user types, basically like, let's say, named tuples for in the Python world. So, there are really features which can't be easily lowered into Onix. And so this is why we use a different format for this. And so like you can, of course, convert our format into Onix. You can try to lower this, but the default path to productionize the models would be slightly different because it would use a different interpreter. Not every framework would be capable of like interpreting PyTorch programs as they are, or definitely like that wouldn't be easy to define the translation.
And so Onix is essentially just a least common denominator for being able to share some subset of the models, or to target that as a means of interchange between different researchers, but not necessarily a full-featured method of deploying the work that you're progressing on into a production environment for end users to engage with.
Yes, exactly. Plus, using a like custom data format allows us to experiment with it a little. So basically, like we can, add more features without waiting for them to become available in Onix and so on. So it's not all that different from Onix, but we have a much, much wider set of operators and data types than Onix supports.
And we're digressing a little bit, but I suppose for just sake of argument, with Onix, would the main use case for having a model in that format be to enable something like transfer learning, where you have generated a base model from some particular set of research, and then you want to share that among other people to be able to leverage within their framework of choice to then build on top of that using the already completed training as part of their workflow?
Sure, I guess that's one of the use cases for Onix. Like ultimately, it's just a format that like many frameworks are supposed to understand, just to kind of make the porting of those models easier. But at the same time, like you need to understand that when you export a model from a framework and like there is an operation which, doesn't have a corresponding op in Onix, it needs to be like somehow lowered into the more constrained format, just because, not everyone might implement this op in this way. So all of basically every conversion between one format and another is lossy, right? So yeah, I guess I digressed a bit. I'm not sure if that's really the answer to your question. Yes, this is one of the use cases for Onix.
Fair enough. Yeah, there are a lot of rabbit holes to go down. It's a big topic area. So can you dig a bit deeper into how PyTorch itself is architected and implemented, and some of the ways that it has evolved since you first began working on it?
Yeah, that's a very good question as well. Basically, PyTorch kind of started as a pure Python implementation. Really, like the whole framework was written in Python, except for the like core kernels that do like the math. Because for those, like if you really want to match performance of existing libraries, you really need this part to like live in highly optimized C and C++. So, but a lot of like all of the, let's say, logic of the framework, like automatic differentiation and so on, we started with an implementation within Python. And then, throughout the history, we've been kind of moving away from this choice. Like we've been moving more and more thanks to C++, mostly from two reasons. One is that some of this code is like really hot, like it's getting executed kind of at every single line of user programs. And so overhead of this code is really, really important, and Python sometimes just can't deliver the same performance. Although, like as an anecdote, One downside is that when I ported part of the automatic differentiation system, which was like 30 lines of Python code, I think it expanded into like a few hundred lines of C++ code that like worked with CPython API and so on. So it's definitely like not easy to convert this, but we've been seeing like measurable and significant performance gains from this. But this is mostly because like it is really hot code that's like heavily exploited by the users. We don't really typically see those kinds of speed ups if like you were to just write your, let's say, machine learning model in Python versus in C++ itself. So this is really only relevant for the library bits. But at the same time, we have some users which are really interested in running models in pure C++, mostly because like they have existing research pipelines in C++, like a lot of reinforcement learning research on games. A lot of games kind of only have C++ APIs. And so those people naturally like started their projects in C++. So they would really like also to have PyTorch features in C++. And this is something that we've been trying to address as well. Like with that 1.0 release, we also have like a beta version of our Python bindings, like of our Python interface, except in C++. So that also required kind of to move a lot of things from Python to C++. Although at this point, we've been so far ahead in this work that it wasn't too hard to actually add those C++ bindings. So today, really, most of PyTorch is just a C++ library and then like a thin layer of Python bindings on top of this.
And so, as you mentioned, you had recently reached the 1.0 milestone release. So can you talk a bit about the journey to get to that point and some of the goals that you had set for that 1.0 milestone?
So the most important goal for this particular release, as I've mentioned, is this research to production path. This is basically something that we've had people asking us about over and over. And so we really wanted to do something about this. And so first, we really wanted to address this, which didn't really require a 1.0 release. But at the same time, like if you really want to convince people that you really think your software is ready to be used in production systems, as it is used in many production systems actually today, you really kind of need to add this like 1.0 tag because it kind of makes it, let's say more formal for a lot of people. So, but, at the same time, this also means that we're kind of declaring that we won't be now changing our APIs as we want. So we're kind of giving up a little bit of flexibility because like we're kind of comfortable that the set of primitives we've settled on at this point is like sufficient to express most machine learning use cases kind of, effectively and conveniently.
And we've gone back and forth a bit with the terms deep learning and machine learning, and a lot of the context where I've heard PyTorch referenced is in these deep learning and neural network implementations, but is it also useful in just a broadly defined machine learning context without necessarily needing to use these deep learning techniques that leverage things like GPUs or highly parallel compute units?
So if you have machine learning algorithms which really don't need this kind of like parallel array operations, which deep learning really needs, PyTorch might not really be the best way to implement those algorithms. Basically, like, usually you will have some kind of bindings, like, for decision trees, let's say, or like gradient boosted decision trees, you have different Python packages which kind of implement those algorithms in C++, but they will not like use the same like set of primitives which like PyTorch exposes. So this definitely is like not a good candidate to be implemented in PyTorch. But on the other hand, I also think that you really shouldn't like limit the use cases of PyTorch to deep learning or machine learning for that matter. Like I really think pretty much in any single place where you use Numpy, this is like a good sign that you really need those parallel operations on, multi-dimensional arrays of data. This is like every single place like this is a potential candidate for PyTorch use, where you might also like exploit some of its features, like, running on GPUs, which was previously not very common for like a lot of data analysis programs.
And do you think that there's room for something like a Numpy compatible API layer for PyTorch to make it possible to drop in places where Numpy is being used to give access to some of that parallelization and GPU computation?
Yeah, I mean, that's definitely possible. And that's also like a relatively common feature request. I guess that we just never had like the manpower to actually tackle this. Like if someone really, really writes this, we'll probably be happy to like integrate this into PyTorch because we know it is somewhat needed. But like there is so much core work and maintenance and in improving like the core features that we have that we actually never like got around to writing this.
And what are some of the other components of the Python ecosystem, particularly in the data analysis space, that are most commonly used in conjunction with PyTorch on a given project?
I think it's just the usual suite of tools that people use to manipulate numerical data in Python. So definitely NumPy is used in pretty much every single PyTorch script because people really like working with NumPy. They really know this API. Apart from this, definitely like SciPy and Matplotlib. Those are kind of the most common, but they're also kind of the most common Python packages. So I guess you'll just find them in like every single, let's say, numerical program written in Python to PyTorch programs. I'm not sure if there's like anything else than those.
And PyTorch is this fairly, not necessarily low-level library, but it's a framework component that is used for building other things with or on top of. So what are some of the most novel or interesting or unexpected ways that you've seen PyTorch used?
I think someone wrote a ray tracer in PyTorch, which was pretty unexpected. I think we have like a library that can simulate physical systems and at the same time like differentiate with respect to the parameters that define them, which is also pretty cool. I think we have like a ordinarily differential equation solver in PyTorch, so it's like definitely not restricted to deep learning as I mentioned. But I'd really like to see more kind of cool use cases outside of this.
And what are some of the cases where you think PyTorch is the wrong choice for a given problem, where it's either overkill or just doesn't really fit the particular use case?
So I think if I was just like someone who wants to not to do any research, I just want to like re-implement the most standard model that's available out there as a result of the research. And I just kind of want to, let's say, take the pre-trained one and just like ship it to a mobile app. There are probably, as of today, there are probably easier ways to do this than with PyTorch, although, we're working towards addressing this issue. So this will definitely get better in the upcoming months.
And deep learning and machine learning and artificial intelligence are areas of active research. And the fact that PyTorch is built in such a way that it's conducive to those activities, I'm wondering, what are some of the overall processes for incorporating some of the new techniques or discoveries that are found in the machine learning ecosystem into PyTorch itself, either as convenience methods or as foundational components of the library?
So definitely, since PyTorch is kind of like a core to a lot of projects, we definitely like don't want to bloat the library with too many things that would end up, not getting used later. So we definitely have a high bar for like accepting, let's say, new methods, like, I don't know, new optimizers or like new functions into PyTorch, unless someone can actually prove to us that like they, have been published, that it was hopefully accepted to like a conference. And there's like a number of papers that build upon this research and actually use those results. And only then like we will actually start considering implementing such things, just as I mentioned, to like limit the bloat, because that ultimately, like if we start putting every single thing into this, deprecation is kind of painful because you always have this like one person who still uses this. And also like it really increases the maintenance cost. And, since we don't have, infinitely many people working on this, it's really important for us to kind of keep the library lean such that we can actually kind of keep reinventing the internals and, improving performance of the things that people most commonly use and just focus on those things. But at the same time, we really welcome all kinds of feature requests. So if you still think that something should be included, I don't feel discouraged from opening an issue. Like, we're really open to discussion. Worst case, we'll just, discuss and decide that this might not be the best fit at this particular moment in time. But, we really want to hear hear back from our users and like what they want. So please do open feature requests.
And are there any areas of ongoing research that you are particularly interested or excited in?
So I'm not, very closely following a lot of the recent developments in, let's say, the latest modeling techniques and so on. So this is not, something that was really exciting lately to me, although there have been some exciting news in this. The kind of part that I've been focusing about lately is the TorchScript part, which is kind of this like programming language thing. And basically there was a lot of people moving from the space of programming languages and thinking how to improve existing languages to like better assist developers of machine learning applications. So I'm really interested in like the collaboration between those two fields, because I really think they can like greatly improve the existing tools. But, the exact way in which that will happen remains to be seen.
And in terms of your own experience of building and maintaining PyTorch and helping to establish and grow the community, what have you found to be some of the most interesting or useful or unexpected or challenging lessons that you've learned in the process?
I think it's the most important to just like always be curious and always be welcoming to people who come to your project. Ultimately, a library with no users is kind of useless. You're really building those tools to like assist them. And, getting any contributors is something you should be really thankful for. I guess I can add that like we've had a lot of luck in having a lot of good people actually come to PyTorch. We have a handful of contributors who we didn't know before we started working on the library, who kind of joined and now like have implemented some of the most important features in the library, or at least helped us a lot in doing this. So we've definitely had a lot of luck in this, and this is something that I'm very grateful for.
And in terms of the overall technical implementation, what have been some of the most challenging or unexpected aspects that you have dealt with in the process?
So PyTorch is a library which kind of touches a lot of the, let's say, systems programming issues. So there's definitely a lot of like interesting stuff that happened and like needed to be solved. Definitely like some of the most complicated ones, I think, are around multiprocessing, because we can't really use threads to like parallelize Python computations, and people will want to parallelize things like data loading. We kind of needed to have a good solution to multiprocessing, to sharing data of our multidimensional arrays between processes. And so this involves like a whole bunch of system level programming. And unfortunately, the like common APIs for implementing shared memory are not super helpful and like super convenient. So I think it took us like 2 years to actually have like a really good implementation of a data loader that like wouldn't kind of, leave memory around if your process crashed, or like made sure that all the sub processes it spawned like will get killed if your process crashes, or like if you actually kill it manually. So there is a lot of things to get wrong in that space, I think. And this, I think, was like where we really kind of spent a lot of time thinking about those things.
And looking forward, what do you have planned for the future of PyTorch in terms of overall improvements or new features or general growth in the ecosystem?
So yeah, we're definitely looking forward to improving the mobile export experience. This is something, so PyTorch is merging with Cafe 2, and Cafe 2 already has like solutions to do this. So this is like one of the biggest engineering efforts happening today, to kind of merge those two code bases. They already like use the same, let's say, C++ level data structures to like describe memory. So we're kind of trying to write this unified library, which will like back both Cafe 2 and PyTorch as of today, and later also integrate like a lot of the nice features that Cafe 2 has, which are, better than PyTorch as of today, to kind of, improve this experience, using at the same time the front end of PyTorch and like the script mode to kind of bridge to this exportable subset. So yeah, I think that's where a lot of things will be happening. And at the same time, we will be working to improve the subset of Python language, which we support through TorchScript, to kind of make it even easier to port user programs and export them.
And are there any other aspects of the PyTorch project or deep learning or your overall experience of building and working on this library that we didn't discuss yet that you would like to cover before we close out the show?
Yeah, I guess it's just that ultimately we know that like there are still things which might get hard to like express using today's tools. And so I'm really looking forward to like discovering like what are the let's say next steps for the whole field.
All right. Well, for anybody who wants to follow along with you or get in touch, I'll have you add your preferred contact information to the show notes. And with that, I'll move us into the picks. And today I'm going to choose the book Unlundone by China Mieville. I've mentioned before that he's one of my favorite authors, and this book in particular is just a very interesting and engaging young adult novel. So I've started reading it with one of my kids recently, and it's great to revisit it. So definitely recommended reading for anyone of any age. And so with that, I'll pass it to you, Adam. Do you have any picks this week?
Yeah, so since we're at books, one of the more interesting ones that I've read lately that my friend borrowed me is In Praise of Copying by Marcus Boone. Basically, I was actually expecting something slightly different from this book because, you know, kind of let's say the topics of copying and like the ethical kind of consequences of this are something that's like really, let's say, discussed today. So, but ultimately the book really doesn't focus on those problems. It really ultimately just is definitely more philosophical in nature. So it actually like just kind of notices that like copying is basically, let's say, the underlying principle of how universe operates. So if someone's a more philosophical type, they might enjoy this, I think.
All right, I'll definitely take a look at that. So thank you very much for taking the time today to join me and discuss the work that you've been doing with PyTorch. It's a project that I've been keeping an eye on for a while with a lot of interest. So I appreciate all the effort that you and the other people working on it have put in. And I want to thank you for that again. And I hope you enjoy the rest of your day.
Yeah, thanks a lot for the invite. And thanks a lot to everyone who listened.